Hi Harriet. Before we get started on today's lesson, let's just get going on our retrieval roulette. So get your workbooks out ready and start to answer these questions. Pause the video so that you can see the questions. Okay, good luck. And here's the answers. So again, pause to mark. Just want to point out apologies about this little typo, apologies, transferred, it's spelled incorrectly. I think the rest of them you can see okay. Okay, so hopefully you have those marked. If not, pause, mark now, and then we'll move on with today's lesson. So a reminder of what we did last day. Last day we looked at what power was, so a definition of power, and we learned how to calculate power. And having looked at your workbook questions from last day, lots of people have got this really, really well, and you're working out top notch. I'm loving it, most people. Now, just to remind you what power actually is, so the official definitions that we would use here are that it's the amount of work done in 1 second or the amount of energy that's transferred in 1 second. So that really means an object can be different levels of powerful, either by how much energy it transfers or how much work it does, or by how fast it does that. So if you have two different objects both transferring the same amount of energy, the more powerful one will be the one that does it in a much quicker time, and the less powerful one will be the one that takes longer to do it. Similarly, if you have two items and they are transferring energy for the same amount of time, the more powerful one will be the one that transfers more energy, and the less powerful one will be the one that transfers less energy. So here's our equation. So the way we write it whenever we're using it is power equals work done divided by time taken. Or remember, because we know work done is equal to energy transferred, then power is equal to energy transferred divided by time taken as well. Now, in the questions you're going to be doing today, this version comes up a lot. So do make sure you remember that these two are the same as each other. It's all because work done is equal to energy transferred, so we can interchange them in the equations. We reminder about units. Power is measured in watts, and we put a capital W for that. Work done or energy transferred is measured in joules, and we use a capital J for that. And the time in this equation has to be in seconds. So if that's given to you in hours or minutes or days, you need to change it into seconds. Okay. So last week we were just doing our calculations on the bog standard version of the equation, power equals work done divided by time taken. Today we're going to step it up a notch, and we're going to be rearranging our equation to either work out the work done or the energy transferred, remember, or the time taken. So we did this whenever we learned our work done equation. We rearranged our equation to make force be the subject or distance be the subject, and it's the exact same process here. So I'm going to go through this. I'm on page 36 in my notes. You should be too, so you can fill this in. So this is our original equation. So power equals work done divided by time taken. If I want to rearrange that equation to make, let's say I wanted to make work done be the subject, then if I look at my equation, work done is currently getting divided by time. So if I do the opposite of that to both sides of the equation to keep it equal, then I will have work done on its own. So if I multiply by time on both sides, then I get power multiplied by time equals work done. So I haven't really left quite enough room here. So work equals power multiplied by time. So that's that equation there. Now, if I take this equation then, I can get time to be on its own, so I can get rid of this power. So if I divide both sides of my equation by power, and I'm doing that because the opposite of multiply by power is divide by power, then I get work over power equals time. So I'll write that one up here, time equals work over power. Now, these are the three versions of the equation. Sorry, it's a little bit squashed here. So once you know one version of an equation, you can always rearrange it to make any of the other components of the equation the subject. I know that is a little bit tricky, but the more we do it, the easier it will get, I promise. So these are the three versions of the exact same equation. One thing I do want to remind you is that these can also be written with energy instead of work done. So this can be written power equals energy transferred divided by time taken, or this can be written as energy equals power multiplied by time, or this can be written as time equals energy over power. Okay, so the questions you're going to be doing today are going to involve you having to rearrange, so you're mostly going to be using these two versions of the equation, and a little bit of changing units as well. The questions today are quite tricky, but I know we can do it. So let's have a little look at these two calculations. In fact, you know what? If you pause the video now and give this a go, then I'll go over it in a wee second. So pause and do it. Done? Better be. Okay, let's look at it. So an electric lamp is marked as 60 watts. So I've listed my power as 60 watts. How much energy does it transfer in 1 minute? Oh, alarm bells. We can't have time in minutes, it has to be in seconds. So we note here, remember energy transferred is the same as work done. So I've started writing the list of information here. So the power is 60. How much energy does it transfer in 1 minute? So the time is 1 minute. To change from minutes to seconds, I have to multiply by 60. So 1 multiplied by 60 obviously is 60 seconds. So now I'm ready to show my proper working out. Always start by writing out the equation, remember? So work equals power times time. So work or energy transferred equals power, which is 60, multiplied by the time, which is also 60 in this case. So 60 multiplied by 60 gets me 3,600. And with my units, look back and see what it is I'm looking for. It's work done or energy transferred, which is measured in joules. So a capital J for that. Okay. Same again with this second one. You give it a go now yourself and come back once you've done that. So restart the video once you've done that and I'll go over it. Okay, so a cyclist has a power of 500 watts listed here. How long does it take for her to do 40,000 joules of work? So this time we're looking for the time. So the rearranged version of the power equation that has time as the subject is work done divided by power, or energy transferred divided by power. So the work done is 40,000 and the power is 500. So 40,000 divided by 500 is 80. And my unit for time, if my power is in watts and my energy or work is in joules, my unit for time is seconds, so 80 seconds. So hopefully you could follow those examples, and remember, if there's ever anything you're not sure about, ask a question in the comments and I'll get back to you. Okay, so here's your classwork for today. We're going to do the rest of these workbook questions, which are on 37, and there's some on 38 as well. So these ones are tricky. Let's have a little look at them. So 14, calculate the electrical energy. So remember, energy, same as work done. If the power is 0.1 kilowatts and the time is 24 hours. So hopefully you can see what is awkward about that one. We do need to do some unit conversions there. So remember, I'll just use this little space here to do some reminders. To go from kilowatts to watts, kilo means 1,000 of the unit. So if we have like 5 kilowatts, that means it's 5,000 watts. So we multiply, what do we equals? Multiply by 100. Okay, so kilowatts to watts, oh sorry, 1,000. We multiply by 1,000. Time, to go from minutes to seconds, we multiply by 60. To go from hours to minutes, we multiply by 60. So you're going to have to do both of those things there. You're going to go from hours to minutes and then minutes to seconds. So you'll end up multiplying by 60 twice. If it was days to hours, let's add that one in, because there's 24 hours in a day. You'd multiply by 24. Okay, so I'll have a wee look and see what questions are particularly awkward to point out to you. Right, so there's a few times in this where like two questions link into each other. So see question 17, a lorry, and then it gives you information about this. Then 18 is also about the same lorry. So how long will it take for the lorry to transfer? So in questions like that, where it's the same thing following on, the power is going to be the same for both of those questions. Okay. So over on page 38, you can see these are labelled as even harder questions. So there's lots of unit conversions as well as the rearranged version of the equations in these ones. And then these ones here, the challenge questions. This is going back to our knowledge of work done, so I'll remind you of that. Remember, the equation for calculating work done is force multiplied by distance. So work equals force multiplied by distance. And you may, in some of these, have to use a rearranged version. So if we wanted to rearrange that to make force be the subject, I would divide by distance. So I get force is work divided by distance. Or if I wanted to rearrange to make distance be the subject, I would divide by force. So work over force. Okay, so 29 is actually not too bad because it breaks up into different things to do. So this one's asking for the work done, and then this one's asking for the power. 30 and 31, you have to think for yourself to use a mixture of the work done equation and then go on and use the power equation. And 31, you can see I've put a star in it. It is particularly tricky. Okay, so give it your best shot. Now, the way you're going to answer these questions, you're going to do these in your yellow workbook as normal, okay, and showing all your working out. But once you have those done, then I have attached to this post in our classwork tab, I have attached a Google form, and it is these exact questions, and you have to type your answers in. So I'll show you what I mean by that now. I'm in the Google form, so I've clicked the link and it has opened up this form. It's asking me for my email address, so I type it in, and remember to use your school email, and it's at c2ken.net. Okay, now question 14, this is where we're starting, because remember we finished off on question 13 last day. So calculate the electrical energy if power equals 0.1 kilowatts and time equals 24 hours. So I have done all my questions in my workbook. So once I have that done, then I go to my Google form and I type in my answers. Now, for this one here, spoiler, I'm going to give you the answer to this one. So I've worked out my answer, and it is 8,640,000. So 864, and then 1, 2, 3, 4. Let me just check that. Yep, 8,640,000. Because this is working out energy, the unit is J, so I put a capital J on there. And then I just move on to my next one. Okay. Now there's a few times where your answer that you'll get on your calculator is a big long answer. If that's the case, I have put in massive capital letters. I'm not shouting at you. It's just to make it easier for it to mark. I've told you what to give your answer to. So you need to round in this one, question 16, you need to round your answer to 1 decimal place whenever you're putting it into this Google form. There's another couple, so this one here, give your answer to 2 decimal places. So round your answer off to 2 decimal places. Okay, so if you don't, this will automatically mark it wrong, even if your answer is correct. And another little thing I wanted to say about that, you'll not get your marks straight away. Because of that, because if you've typed in something maybe slightly differently than the way I have put the answers in, I want to review your answers, and then I'll release the marks a little bit later on, and then it means I can fix hopefully any mistakes that the system has made. So you'll not get your mark for this straight away, but you will get it a little while after. Okay, hopefully that is obvious enough. So time to get on with it. Okay, good luck. Remember, ask for any help if you need it. Bye.